Hi everybody, it's Mrs. Dinkelman, and in this section we're still doing volumes of revolution, but we're going to use a different new technique that normally we don't learn in AB because it's not required. All the problems in AB you could do with a disc washer, and in BC there are some times when we run into problems where we can't use the disc washer, so we're going to have to choose this method. So that's why I put example 1 in here. If we think about what this graph looks like, and I did put it on Desmos real quick so we could kind of see x squared minus 2x cubed, and I'll show you how I would do it by hand. So we're talking about this little teeny tiny piece here above the x-axis. If I try to take that and rotate it. So let's kind of make a picture for ourselves. So if I factor out the x squared, by the way, 1 minus 2x, then I know that this thing crosses at 0 and at 1/2. And I'm not going to put labels there for just now. This is also an x cubed, but it comes down from the other side. So let's see, it came down and bounced and then went back up like that, something like that. Okay, so it's that part we're rotating, and sometimes for me I draw the whole thing and then I just erase kind of the piece I don't need. So we're going to try to take that and we're going to try to rotate it around the y-axis. So what I would do is, for me, I'd like to draw another copy of it, and then I try to draw, I don't know where it went, then I tried to draw a washer. I did a better job the first time. So this is really a dy problem, because if I change the thickness of that washer, it's going to change the vertical component, which is a dy then. Well, that means with this function, what I want to try to do then is get it to say x equals. Well, that's going to be near impossible to try to isolate x by itself because there's so much going on. So this is why we need another technique so that we don't have to do that. And if we could leave it in dx, it'd be really helpful. So that's when cylindrical shells come into play. And I have some pictures here. So this picture is back to the functions we were talking about in last section, the square root of x and x squared, just rotated around the y this time. So we're going to take that little strip and we're going to rotate it around, and you can kind of see those cylindrical shells in this picture and here. What we would really want is an infinite amount of them. So I just kind of have both pictures there. What I want you to know about the cylindrical shell is to think about area. So I have this piece of paper here. Imagine that this is one of the cylindrical shells. Well, to find the area of this, because it shouldn't have thickness, if we have an infinite amount of them, we need to basically find the area of this rectangle. Well, the way we're going to find this measurement is really the circumference of the circle. So that's going to be 2 pi r, and then we're going to need the height of that, so h. So in our formula here, if I scroll down a little bit, if it will let me, here it is. You can see here in our formula that we have the 2 pi r, that's really the circumference, and then we have the height in there as well. And then the dx or the dy is what makes it a volume. So I think this kind of rolls off the tongue pretty nicely. I just kind of in my mind think about this base 2 pi x f of x dx or 2 pi y f of y dy. The only adjustments we have to make to that are if the radius is, we're going around an axis other than the x or y, the radius would need to be adjusted. So instead of an x or just a y there, we're going to have to make an adjustment. And then the height, if we have two functions, then we're going to have to just adjust the f of x because it's going to include two functions. Okay, so back to that example we were talking about. This is just around a normal axis, and maybe I could kind of draw a picture back up here where I had this. So sometimes this is what I do. I just draw the disc washer and then realize it's not going to work for me, so I kind of just change it into a cylindrical shell. We're going to pretend for a second that it's a cylindrical shell. Oops, it wants to move on me. I just like to draw on top of that. When we get to the next section, we'll talk about how we make that decision. So I'll give you some advice on that, okay? So we're just going around a normal axis. This should just be a 2 pi x f of x dx. Again, we want it to be just an x because we don't want to have to figure out what's going on with dy. So earlier we found 0 to 1/2, 2 pi x f of x dx. That 2 pi can come out just like in the previous one. We would put the pi out there, and you can put the 2 pi out there if you want. This time in example 2, we're revolving around a different axis. So this is just me trying to show you how we adjust for the radius. So it's going to be 2 pi instead of x. Again, normally it's 2 pi x f of x dx, but the radius is a little bit different. So let me draw a picture of that little piece again. So if I take that And that's at 1/2. I know my scale might be weird, but I like to make a little copy-ish of that over here for my own brain sometimes. The way I draw the shell is to just kind of put like a little rectangle here, kind of like the Riemann sum. Make a copy over here about the symmetric location, and that is what we're looking for. Okay, so our radius goes from here to there. Now, if I had drawn the cylindrical shell all the way out here, the radius would be 2 exactly. So this one is a little bit less than 2. Well, how much less? Well, wherever I chose to draw that, that's the x value I chose to draw it at. So how much less is it? Well, it's whatever x is. So if I had drawn this at 0.25, then I would know that my radius for this one is 2 minus that little 0.25. So we're just going to go 2 minus x in here. So our radius is a little bit smaller than 2, if you kind of can think of that visual. Okay, so as you're going through this assignment, quick reminder that these are all going to be cylindrical shells, so just practice that. And then in the next section, we'll talk about how you determine or how you decide which one you're going to use.